All right, welcome back to game programming for 2D game engines. Let's take a step back from the code base for a second. Before we dive into that, I want to give us some context for what we're going to be looking at, what it is that we're going to need to do. So, let me start with the game engine architecture, how all of this is meant to work together. All right, so what is it that a game engine does? This is something that if you haven't really thought about it, can be kind of daunting. Well, there is functionally nothing to it. It is a big loop, specifically. Transparent. It's a big old loop. And what this is doing is super nice curve that I drew here. Made even better by the fact that you can see it twice. So we have a big loop, and that we're going to be using to do things. So if we're talking about specifically a 2D game engine, so we're going to be doing drawing everything and updating everything. If you've taken some classes with me before, we deal with game architecture or game modding. This is probably not news to you. In the world of game mod, the game engine that we worked with does this for us. It is running in what is called busy waiting. We're designing a system that is serially robust. Serially robust is a term that kind of makes everything feel like it's running in parallel, but is in fact being run in series. But it is robust. So what happens with everything? Well, we're going to keep a track of all the things. So the everything is going to consist of the game world, which might be tiles, might be hand-drawn backgrounds. You can have parallax effects, lighting masks, all kinds of things like that. Then we have the game entities. Remember, an entity is anything that can act or be acted upon in the game world. We'll have other special effects like particles, trails, shadows, smoke, bullet explosions, whatever it is that your game needs. Those special effects need to be updated and drawn every frame. User input. Now, user input doesn't get drawn, but does need to be updated every iteration of the loop. And for language purposes, I'm going to refer to one iteration of the loop as a game frame. Now, frame is a term that gets used a lot. There are server frames, there are client frames. Some things operate at a higher frame rate than others. There's animation frames. But as far as what we're going to be talking about today, I'm talking about a single iteration of the game world. We've drawn something, or we've updated something. And that can be in either order because you can see it's a loop. So they basically just alternate back and forth between drawing and updating. In fact, instead of drawing them top to bottom, it's probably better to think of them as other sides of the loop. Draw everything and update everything. All right, there's the game. There's the game engine right there. Update everything, draw everything in either order. So we are user input. We're going to network updates. So check to see if there's a new state frame that came from the server or from a new input update from other clients. All the things that we need to do for managing that. We need to run monster AI, world objects, event triggers, user interface, mouse, if there is one, and so on and so forth. So this is what a game engine does. It manages everything. Now, before the game engine begins, there is a stage of initialization. So before we even get here, there is a need to load everything into memory, configure rendering pipelines, configure the screen, make the windows, load all the graphics, load all the sounds, load everything. And then the game will run in loop until such time as either the user decides to quit or the game crashes, which, since we're all new programmers here, is going to be probably more often than you'd like. That's fine. That's part of the process of learning how to be a better programmer, is to make a lot of mistakes along the way. Now, let's talk about game engine responsibilities. In game mod, I talk about mostly the game logic, how we use the capabilities that a game engine provides us in order to make the game experience specific to whatever the vision happens to be. But now let's talk about what those capabilities from the game engine are. First thing is resource management. Cool thing about game engine programming is that you really get to cut your teeth on the whole idea of memory management and resource management. A logical next step for making your own game engines is to make your own operating systems, because the two are pretty similar in scope and goal. With an operating system, you're managing applications and tasks and memory and other system resources. So too, similarly, are you doing in a game engine, but you're managing a specific simulation of game objects and entities and things. So what does a resource manager need to do? It needs to be able to load or create a resource. We need to be able to utilize that resource. And when we are done, we need to free or clean up the resource. Let's keep the capital consistent. I am not consistent with capitalization. I guess in this case, clean up is the action. Anyway, now what kinds of resources are we talking about here? I'll just list a few of these out. We're talking about images, sprites. So when we're talking about graphics loading, the sample code has a resource manager shown to you in the sprite management system. That is going to be your template for building out other resource managers. Also in GFC, there is a sound effect resource manager in the audio, the GFC audio header file and C file. Again, GFC is also open source. You can see the code. You can use it as a template. You can see there we load the sound effect. We have functions to play the sound, and we have functions that will clean up the sound. More broadly, before I go listing any more resources, there is the all initialize and the all delete or cleanup. Is cleanup one word? I guess cleanup is one word. There, now it looks better. So when the system loads, like I said, before we get to the game loop, everything needs to be initialized and loaded. So the system needs to be initialized. Then when the game closes, everything needs to be cleaned up. And in the meantime, on demand, we're going to load a resource, utilize it. So what does utilization mean? For an image or a sprite, it means drawing that to the screen. For an audio file, it means playing that sound. For a font, it means rendering the text as an image. For an entity, it means running its updates and its thinks and handling collision and things. For particles, it is probably just applying whatever deltas need to be added to the particle in order to then render it. And also render it. So update and render. And when we're all done, we need to clean up. This is something where I get to do my little Uncle Ben's speech, or Aunt May if you're more of an MCU person. Spoilers alert. With great power comes great responsibility. When you're writing your own engines, when you're doing any kind of like real low level, close to the metal programming, when you're programming in C and C++, you have great power. You have direct memory access. You can access the hardware at a level that most languages try to abstract you away from. With that power comes responsibility, because if you fail to use that power responsibly, your system's going to crash and it's become unstable. So I say we need to be responsible stewards of whatever resource we're dealing with. There is the alpha and the omega. Whatever we create, we also destroy. So that once we are done with any one resource or the system, everything that we've used is given back to the system. We came from mud, we're going back to mud, kind of a thing. All right. Audio, sounds, music. Fonts are a resource. As I said, entities are a resource. Events might be considered a resource. Particles and effects can all be considered resources. And I'm sure we could name more and more of them. In fact, the world itself, although we're most likely will only ever have one at a time, could be considered a resource that can be managed. All right. Something else. Let me, resource managers continued. I'm glad I didn't make these ahead of time so you can spend time watching me type. And no, I'm not going to edit it out. You're going to get to look forward to me typing all semester. If anything, it should give you some hope that even in my advanced stage of my career, I'm still mistyping everything the first time through. And I'm remarkably dyslexic, so I oftentimes type stuff out of order. Anyway, enough of that. So there are two styles of resources that we manage. Singletons and shared resources. What do I mean by that? Shared resource is, say, an image or a sound effect or a single particle. So when I load the mouse sprite, or if I load a player sprite or a goblin sprite or a rat sprite, if I ever need that same rat sprite again, I don't need to load it again. What I do here when I have shared resources is I keep track of reference count so that I can go through my global list of resources and see when, hey, I want the rat image. Do we have the rat image? And we can say, yes, we have a rat image, and here you go. And now we've got two people using the rat image, the one rat entity and this other rat entity. And then when I go to delete the resource, I don't actually delete the resource. I just decrement its reference count. I'll only free up that resource when I need space and there's a resource that currently doesn't have anything referencing that specific resource. So I've killed all the rats in the level. I don't need to load the boss. The boss doesn't need any rats. But the boss has a whole bunch of sprites to load. So maybe I'll reuse that resource at that time. And in the future, if I need to load up another rat, I can hit the disk again and take that resource hit, that time hit. Singletons, on the other hand, every resource is unique. Track if the memory is in use. And these are for resources like entities. Every entity is its own unique thing. I can have, going back to the rat model, I can have 15 rat entities. They're all based on the same stats of a rat. They're all using the same image of a rat. but they have their own position in the world. They have their own action that they're currently doing. Their current frame of animation, it may be different. Different health, different targets, different status effects. They are unique entities. So entities are a singleton type of a resource. Another one is the particle. Now, I made a quick addendum here while I was typing out and explaining the other thing, but a particle type. So I have a smoke particle, a fire particle, a laser sparks particle as a type. But every individual particle has its own position in space, its own time to live, and then once it has exceeded its lifetime, it will clean itself up. That particle resource is shared. The actual particle instance is not. I even have more things like, say, player data. Quake did that. They had the client data that was separate from the entity data, and it just happened to be that the first 16 entities happened to be earmarked to be players. Everything else was monsters. So entities, particles, monsters, so on and so forth. The world itself, whatever that is, if I have a tile map, like I said, or I've got some kind of parallax background or something freeform drawn, the level 1 Green Hill Zone is very different from level 2, the sewers. And I don't have multiple copies of it in memory. It's generally treated as a singleton. All right. Now let's finally take a look at... oh, look at that. Game engine architecture. Cool. Finally... So let me add one more here. Control M. No, I don't want to copy that one. You don't need a title screen again. No, do it this way. Game engine initialization. I talked over this, but let me make a slide on this. So this is initializing all subsystems, which include the graphics engine. In our case, it's SDL. If you take 3D game programming with me, it's going to be based on Vulkan or some other thing. The font system. We need to load up the fonts. We need to worry about our menu system. So now what kind of windows and widgets are we going to have? What kind of window elements are going to work? And then actually even before that, we're probably going to need our image sprite manager, our sound manager, load defaults, all that fun stuff. And then let's duplicate this slide. No, not delete, duplicate. We are now need to de-initialize all the subsystems. And the cool thing about initialization of systems, and this is something that's going to be important, that is going to trip you up in the future when all of a sudden you try to turn something on and you're cleaning up code and everything starts crashing. Because generally, the order of initialization matters because there might be some dependencies. I can't have my image system or my font system without my graphics system. I can't have my entity system without the image system and the sound system, and I can't have the menu system without the image system and the font system. You are then going to do it all in reverse order. We're going to free the defaults. We are going to de-initialize the graphic system. We're going to de-initialize the font system. And there we go. It'll be reverse order. Reverse order of initialization. Now, when you're designing the system out and adding additional features to your games, it's going to have you might get a situation where you want some circular dependencies. I want my entity system to know about my graphics, or to know about my world system, but I also want my world system to know about my entity system. So when I'm cleaning up the world, I'm going to have to free all the entities. But I've already freed all the entities, so I can't free all the entities, so that part of my code tends to crash. It's going to be a confusing and complex problem to solve when you get to that point. A lot of it's going to be based on decision making and how you're going to design the architecture. You need to keep track of who owns a resource. And who is responsible for cleaning it up. And only the thing that owns the resource is responsible for cleaning it up. I can say I'm done with it, but you're not going to delete it until who the owner of it cleans it up. All right, let me end this video here. In the next video, we're going to dive into the code and see how the game framework works from the code level. All right, thanks for watching.